Hi, Ami. How are you doing?
Hi, sir. Yeah, I'm really good, thank you. How are you?
Very good, very good. So today, what do you want to do?
I was just thinking that like trying to revise. I guess the best way you always say is to do exam questions. So I was thinking if we could just do like a couple from like various topics just to get an understanding. Because when you know the topic and then you do exam questions from it, it's easy because it's like you're already in the mindset. It's when you suddenly get like into so many different topics, it can be quite hard to remember even like the easiest of formulas when we do in class together.
Right.
So I thought that would be quite helpful.
Yes, a great suggestion. So let's see how do we solve a test paper. So pick up some test paper and share with me. We'll solve it and do our best.
Yeah, we'll do our best. Okay. Uh, so can you see my screen?
Yes, I do. So let me
Okay.
have a seat.
These are all a bit random, so
Okay. So that's good. It's like exam, true exam. All the questions are randomly coming, right? And
right.
most of
Yeah.
the topics are covered for you. So that's a good thing. Okay, so let us go.
Um,
Can you please read
Actually,
the
though, um, I haven't done like year 13, obviously, content. But in this exam question, if there are questions that we can't answer, maybe I actually haven't done it. So yeah, I
Okay,
don't know. It's not easily split.
that's true. So let me write year 12 and 13, correct?
Slash 13. Yeah, yeah.
Okay, so let's read the question. Let's try to see how do we solve it.
Okay. So 7i. Use logarithms to solve the equation 8 to the power of 2x plus 1, which equals 24, giving your answer to 3 decimal places.
Correct.
So take logs on both sides.
Correct. So basically, you're right. So take logs on both sides. You could do that part, correct? Because it is saying three decimal places, right? So there is
Mm,
that is the best way to do it. So yes, so take logs on both sides. So when you do, let me rewrite this equation with logs. We say log of 8 to the power
8.
of 2x plus 1 equals to log of 24, right?
Yeah.
So using the properties of log, 2x plus 1 can be written like this, right? That is the power, it comes here, log rules, power rule. And we have log 8
Yeah.
equals to log 24. That means 2x plus 1 is equal to log of 24 divided by
Divided by.
log of 8. Since you have to use the calculator, you need not do 24 minus 8 and simplify. No need, right? So you'll just
Yeah.
write an expression, take one that side, so you get log of 24 over log of 8 minus 1, and clearly x is half of all this, right?
Yeah.
So log of 24 divided by log of 8 minus 1, and you can use your calculator to solve this. Perfect.
Yeah. So I got, just for reference, 0.264 to 3 to dp.
0.264. Okay. So we'll assume that to be the right answer. You can always check. So now do 8 to the power of 2 times 0.264 plus 1. What do you get? So just check, right? So we get
2.
8 to the
Oh,
power of
yeah.
2 times 0.264 plus 1, right? So
1.528. 8 to the power of 1.528. 23.98.
9. So this gives you 23.98, which matches with your 24. And therefore,
Right.
that's the right solution. Is that clear?
Oh, okay.
Perfect.
Yeah, that was really important to check back to see if it's
It's
right.
easy.
I know it's an easy, like it's an obvious thing, but like right now when we're doing an exam, I just thought of the answer and then I moved on. It's good to get in the habit to put it back because I won't have time to like go back and check. So if I check now, at least I know when I move on, I'm like, sure, that's right.
It takes
That's a
one
good point.
second. It takes 1 second and gives you confirmation for 3 points. Is that okay?
Yes.
Very important, right? Next question, please.
Oh, so just another quick question. With that logs one, do you ever have to take like the same like base with logs? You know, like
Yeah, yeah. So
2 or like
correct. If they are not
I
of the
don't
same
know.
base, we may have to change the base of logs. In this
Oh, do you?
example, all yes. In this
Okay.
example, all are to the base 2. So that should be simple. So you'll
Okay.
apply log rules, right? And solve this particular question. So can you, okay, the question here is find the value of y such that log to the base 2 of 11y minus 3 minus log to the base 2 of 3 minus 2 times log to the base 2 of y equals to 1. And we are given that y value is greater than 3 over 11. Okay.
Yeah.
So basically all are to the log. So you can use the logarithmic rules. You can log to the base 2 of whenever it is minus, it means division, right? So you get
Yes. Yeah.
11y minus 3 divided by log of the base 2 to the base 3. And then we have also minus 2. So this means y square, right?
Oh, yeah, because the 2 was brought down. Yeah.
Correct. So that means y square equals to 1, correct? So you may rewrite here one step, writing this power to that point, right? Y square, and then do it. Is that clear to you?
Yes, yeah.
And now a log of 1, that is 1. And when will this be 1?
When that whole thing equals 2?
0.
Oh,
Only
0.
then it can be 1. So this whole thing has to be 0, right? So we have 11y minus 3 over 3 times y squared. That should be equal to 0. Is that okay? Because we know that, yeah.
But what happened, you know, if like when I in my calculator, when I did log 2 and then in brackets 2,
Oh, sorry, it should be 2, right? Sorry.
Oh, okay.
Because anything.
Wait, so when is it 0?
Anything
when it's 1.
Anything to the power of 0 is 1, right?
Yeah.
Anything to the power of 0 is 1. And therefore, all this should be, you need 1.
2.
All this should be 2, right?
Right.
So if you look into the log graph, I wanted to say 2 to the power of 0 and messed up. Okay, anyway. So basically, logarithmic graphs is kind of like this, right? And you're looking for this particular value when it is 1.
Okay.
Yeah. So if you're looking for 2 to the log to the base 2, right? X base is 2. So when you get, it has to be x is greater than 0. Is that clear to you?
Yeah.
X is greater. So when it is 2 to the power of 1, it gives you 2, right?
Yeah.
Since you want this to be 1, that basically means x equals to 2 to the power of 1. That means x equals to 2. Is that clear to you?
Yeah.
Log to the base 2 of x is 1. So we have to equate all this to 2. So we get a quadratic equation. So we can solve this quadratic equation. So we now have, let me change the ink. We have 11y minus 3 equals to 2 times 3 is 6y squared. So we can rewrite this as 6y squared minus 11y plus 3 equals to 0. Now we can factor this. 6 times 3 is 18, right? So 9 and 2. So you get 6y squared minus 9y minus 2y plus 3 equals to 0. You can factor this. You get 3 common, 3y common, right? So we get y minus 3, 2y minus 3, and take minus common. You get 2y minus 3 equals to 0. So 2y minus 3 is now common, and you get 3y minus 1 equals to 0. So that gives you two values. One is y equals to 3 over 2, right?
And a third.
Y is 0 2, and y equals to 1/3. You're also given the restriction that y is greater than 3 over 11, correct?
Yeah.
So is it, if I do 3 times, I get 3 over 9, correct? Is that clear?
Wait, oh yeah, when you times a third by a 3. Yeah.
3 over 9, correct? So 3 over 9 is greater than 3 over 11. So this is also a right answer, correct? And 3 over 2 is definitely the right answer because
it's 1.5.
More than 1.4. Is that okay?
Oh, right.
So we have two solutions for this, and they are 3/2 and 1 by 3. Is that correct? So we have two
Yes.
solutions for this particular case.
Okay.
So
So yeah.
if you're not very sure, you can check the calculator, because calculator is allowed for this. What is the decimal value, right?
Oh yeah.
1 over 3, you know,
0.3 recurrent.
333, and yeah. Okay. Now we've done these two. Is it absolutely clear to you?
Yeah. So can I just like highlight the key
Summarize.
stuff that
Yeah.
I learned? Yeah.
Yeah.
So in the part one, what we did was so we're looking at this. It says use logarithms, so you have to like just take logs on both sides, use the logarithmic rules, move it around, and you get your value. But the key thing that I didn't do, but now will do, is after you find your value, you want to try and just sub it in. It takes a second to do it. And when we did it, we found that the value was basically 24. So you really want to do that just to double check, because it's nice to move on, like feeling confident that that's the right answer.
Perfect.
And then for part two, we just, so it looks all complicated, but it's all about just knowing those log rules. Because when you see the minus, you know that we're talking about dividing, and then knowing log 2 and then the base of 2 then to the 2 equals 1 is really important. Just to solve the equation, you get a simple quadratic and then factorize.
Perfect.
And then make sure those two values are satisfy your domain.
Within. That is very important. Good job. So you can share another question now.
I think it's probably a different topic.
Okay, good. Yeah, let's do this. So can you please read the question?
Yes, sir. So solve for theta where it's in between pi, 0 and pi, yes, with 0 included. Sine 3 theta minus root 3 cos 3 theta is 0, giving your answer in terms of pi.
Perfect. So this is a very simple question. We'll take cos theta to the other side. So we get what? So we get sine 3 theta equals to square root 3 cos 3 theta, correct?
Yeah.
Now we'll divide both sides by cos 3 theta.
So we get tan 3 theta.
So we get tan 3 theta
equals
square root of 3.
Root 3.
You know the special triangle? As soon as you see root 3, you should look into the special triangle. Is it okay?
Oh, okay. Okay.
Now in special triangle, this is 60 degrees, but they want it radians, which is pi by 3, right?
Yeah.
In that case, the sides are 1, 2, and square root of 3, correct? So tan of pi by 3 is square root of 3. Is that clear to you?
Yes. Yeah.
So square root of 3 means basically tan of pi by 3. Is that okay? So that means 3 theta equals to pi by 3. And theta will be equals to pi by 9. Is that clear to you? Now, one thing, yeah.
Oh, wait. Sorry, yes, I did actually lose you for a second. Okay. So wait, so
internet connection.
Yeah, could you just repeat that, please?
Yes. Tan 3 theta is square root 3, as you can see from the special triangle, right? So tan theta is the ratio of opposite
over adjacent.
Over adjacent, right? So which is square root 3 for pi by 3. So instead of square root 3, I wrote pi by 3. Tan of 3 theta, therefore, is equal to pi by 3. Solve for theta. Pi by 9. Okay? Now,
but why instead of root 3 did you write pi over 3?
Because tan pi by 3 is root 3, right? Correct?
Oh, that was so, whoa, I'm mind blown. I did not see that. But like I would never in a million years have done that.
Okay, you want pi between 0 to this, and the question says 3 theta, right? Do you see that?
Yeah.
So we are saying that theta is between 0 to pi. So if I divide this by 3, everyone, right? So what do we get? We get that we are looking for theta. Oh, sorry, I have to multiply by 3. I'm sorry. 3 theta, right? 3 pi.
Oh, yeah.
Sorry, not divides.
I think because it was pi over 3. You thought divide 3.
Yeah. I was looking into the solution, right? What we got. Anyway, let me redo this, right?
Tans cancel.
Okay, so 0 less than equals to 3 theta, 3 pi, right? Do you see that? 3 pi?
Yeah.
So that means 3 theta could be between 3 pi. Now, 3 pi
Right.
really will give you another solution. So that's kind of important to understand. So when you have the cast rule, so 3 pi means what for you? So it is 1 pi, then another pi, and another pi. Do you see that?
Yeah.
So there are more solutions than what we have just given.
Oh, so that's when you need to add
Here
the
we
180.
add the cycle of tan theta, which is pi. You get the idea?
Oh, pi,
So
yeah. Sorry,
basically,
in
yeah.
degrees.
So basically, you get 3 theta equals to 1, of course, we got pi by 3, right? So that is one answer. So let me show it here, pi by 3, correct?
Yeah.
Then we will add pi
Pi.
to it. So we have another answer, which is going to be this, correct?
Yeah.
So then we have pi by 3 plus pi, correct? Then we'll again add pi to it and come back to this place.
Right. So,
But because, 1 pi, 2 pi, and 3 pi, right? So we could go one more time, right? So then we'll add pi by 3 plus 2 pi, right? Do you see that?
yeah.
So calculate these values. Are they less than 3 pi? They
Wait,
are. Right?
I need to be in radians, yeah? Okay.
Yeah, when you write pi, it is radians.
Right.
So pi by 3 is the first answer. Then you add pi to pi by 3. That means 3 pi plus 1 pi, 4 pi by 3. Sorry. 4 pi by 3, right? These are the value of 3 theta, okay? And then you're adding 2 pi to it. 3 times 2 is 6, 7 pi.
Okay. Yeah, yeah.
And therefore, you're going to divide each by 3 and you'll get the other answers, which will be 4 pi by 9 and 7 pi by 9. Now you should check. 7 pi by 9 is less than pi, correct?
Yeah.
So these are three
So
solutions.
they're in the domain. Yeah.
There are 3 solutions for this particular question. So it is not that it was easy calculation to begin with, but
Yeah.
now to see how many solutions are there in the given domain, because we have
Right.
3 theta, not 1 theta, 3 theta, right?
Yeah.
3 times. It's kind of like this, think like this. So we expected 3 solutions in the domain 0 to pi. Is that clear to you?
I see. Yeah, yeah. So the moment we see, so let's say because they've given us the domain as theta, if they put like 4 theta, 5 theta, you should be, even before you answer, you should know that there should be so many, like at least a lot of solutions.
Correct.
Because you're going around so many times.
And keep on adding. So if I now on this add another pi to it, because the period for tan is pi, correct?
Right.
So if I add another pi to it, 2 pi plus pi is 3 pi. So I know I'm going away from my domain, right? So
Yes,
we want to restrict till 3 pi for the value 3 theta. Is that clear to you?
Very clear.
That is how we are going to solve it.
Wow.
Perfect.
Yeah. The most mind-blowing thing for me was when you wrote the root 3 as tan pi over 3.
A special triangle. So special triangles is very important to remember. As soon as you get square root 3, square root 2, or related terms, 1 over square root 3, something like that.
Right,
Please, you have to look into your special triangles, correct?
Oh, okay.
And then get the answer.
So if I didn't sub in tan pi over 3 as root 3, can I divide the root 3 by anything, or is that the only way?
You will do tan inverse, right? Then you will say like this, let tan of beta, some acute angle, right? Equals
equals root 3.
right? So then beta equals to tan inverse, bless you,
Of root 3.
3.
Oh, yeah.
And then you will get beta equals to pi by 3. So we got the related acute angle. So you could find the related acute angle. Is it okay?
Yes, yeah.
And then other answers. Is that okay? And then your other answers.
Yeah.
So that is a normal strategy. But this was like root 3. As soon as you see, you should check the special triangle.
Yeah. I just want to get in that habit,
Yeah.
like you went straight to it. Okay.
Let's look into the next question. Yeah, what is the next? Given that 4 sine square x plus cos x equals to 4 minus k, and now k is between 0 to 3, find the value of cos x in terms of k, right? So you need to find cos x, simple thing. Sine square x can be written as 1
1
minus
minus
cos
cos
x.
squared x.
So let's do that. So we have 4 times 1 minus cos square x, and then we have plus cos x equals to, so we'll bring all the terms to one side, right? So we'll say minus 4 plus k equals to 0. Does it make sense?
Yeah.
Bring all these terms to this side. Okay, but remember the restriction while you're solving. So let's open the bracket. We get 4 minus 4 cos square x plus cos x minus 4 plus k, right, equals to 0. Now 4 minus 4 gets cancelled. So you get minus 4 cos square x plus cos x plus k equals to 0, correct?
Yeah.
I prefer to write positive leading coefficients. So I'll make
Yeah, me
everything
too.
4 cos square x minus cos x minus k equals
Minus k.
Now, this is a quadratic equation, so you can apply the quadratic formula. And when is it 0? You can figure this out. Is it okay now? So what is
Yeah.
the value of x? So they're saying, what is the value of cos x? So cos x equals to minus of
Y.
is 1 plus minus b squared, which is 1, minus 4ac. So minus minus becomes plus. 4 times 4, 16, 16k, right?
Wait.
Over 2 times a, which is
So could we is it just asking as a other method, because when I saw that I was going to do like let cos x equals y and then you do 4y squared minus y minus but because there's a k there, is that annoying?
No. You could do, I mean, see, of course, you want cos x, right? You can substitute cos x as y. You could do that.
Oh, okay.
But I think it is unnecessary.
It's better to go straight to it.
Yeah. You could do this, right? Minus y equals to 0, right? And then apply the formula.
Okay.
And then replace y with, of course, you need cos x value, which is y, right? So cos x is y. No harm in this. You will write y equals same equation, minus 1 plus minus square root of b square, which is 1, minus 4ac. So 4 times a is 4 and c is minus k. Is that okay?
Yeah.
Minus and minus will later become and 2a, which will be the same answer which we just got. Is that clear?
Right. Yeah.
Now remember, the value of k is between 0 and 3. So you can write this, that k is between 0 and 3. Is that clear to you?
Yeah.
Just right. We'll calculate later and see what it really comes to. Since definitely we know that cos x value cannot be more than plus minus 1. Is that clear to you?
Right. Yeah.
Absolute value of cos x is less than 1. Correct? So we'll see what the value of k could be. It will be almost that much. Is it okay?
Yeah.
So you can see, if I put 3 times 16, so 3 times 16 is 48 plus 1, 49. Do you see that?
Yeah.
If I put 3, see what happens? 1 plus square root of 1 plus 16 times 3, right?
Yeah.
Over 8. So we get 1, I should have 1 plus minus. 1 plus minus. I'm writing 3, right? So 49 is 7. Do you see that? So that gives me 1 plus minus 7 over 8, right? Do you see that? 1 plus 7 is 8, right? 8 over 8 is 1. Do you see that maximum value?
Yeah, and it fits in
and then you get minus 6 over 8. Do you understand? Minus 6 over 8, which is again negative, but less than 1. What I'm trying to say is, right?
Minus 0.75. Less
than 1. So it is within the domain. So that is why they're giving you this domain. Do you understand?
Yeah.
If they would not have given this domain, you could derive at it. So the beauty is, what could be the value of k? That could be a very brilliant question. So the question which I could have asked here is, find what is domain of k, right? So I will not give the domain of k between 0 to 1. Let us see. I can say k is a positive real number find the domain of K. So maximum value could only be 3. Do you understand?
Yeah.
Because the maximum value of cos x could only be 1, right?
Yeah.
Plus and minus 1. So if you
But
put
would
1,
but for yourself to figure that out, you have to do trial and error, or is there?
no. You
Oh.
know the maximum value is 1. So you'll put this value
Oh.
equal to 1 and solve for it, correct? So 8 times 1 minus 1 is 7. So you will square 7, you get 49. 1 plus
Oh.
16k is 49.
Just
Subtract
working
1 and
backwards.
divide by 16. Yes. And then get the value of k as 3.
Oh. Oh my
Yeah.
God. Yeah. That's a good question.
So
Yeah.
this could have been a very great question, not giving the value of k, but asking it as a part, let's say,
C or D.
yeah, wherever. What
Yeah.
I mean, what could be the find the cos x value in terms of k, and then B is what could be the domain of k. Is that clear to
Yeah.
you? Okay, great. Now, B, can you please read the question B? I think we have answered that part. When
Wait,
k
so is that the answer, sir? The 1 plus 1 plus 16 over k?
Yeah.
We don't need to
When,
simplify or anything, do we?
so B is when k equals to 3, find the value of x in this domain, right? So that means we are looking for a value of cos x equals to 1 or minus 3 by 4. Is that okay?
Yeah.
Let's calculate it. So let me, so what you need to find is, can you do that part? Did you understand all this?
Yeah, very clear. This is all part A. And the answer to part A is the 1 plus or minus square root 1 plus 16k over 8.
So all clear. So we got this answer for 1 is cos x equals to 1 plus minus square root of 1 plus
1 plus 16k
over 8. Is that okay?
Yes.
Now, so we got this. Second part is when k equals to 3, find the value of x in this range up to 360, right? So when you substitute 3, we get cos x equals to 1 plus minus. We did this part.
You did.
Yeah, without.
You already did it.
Yeah, over 8. And we solved this, we got 1 and minus 3 by 4. Is that okay?
Yes.
Now, since we want to answer this particular part, that we are looking into two solutions, 1 or minus 3 by 4.
3
and
or 4.
again, apply the cast rule, right? So let's do 1 by 1. Cos x 1 is very clear to you. Cos x is 1 between when it starts with 1 itself, right? 0 is 1.
Yeah.
So if you draw the cosine graph, you know the cosine graph is kind of like this. So 1 gives you two solutions, which is 0 degrees and 360 degrees. Is that clear to you?
Yeah.
And now with minus 3 by 4, we know we are in quadrant 2 and 3, right?
Yeah.
So 2 and 3. So we'll do cos inverse of beta. I mean 3 by 4. Let me do 3 by 4. We'll find beta, right? Beta acute angle. Let me.
Also 3 over 4.
Yeah, I want to write 3 over 4. So what I'm trying to do here is we'll find, let this be acute angle beta. So I'm saying cos of beta is equals to 3 by 4. So beta is equals to the acute angle, the related acute angle, cos inverse of 3 by 4. Can you tell me, calculator?
41.4 degrees.
41.4 degrees. And now we are looking for two solutions. One is in quadrant 2 and the other one quadrant 3, right? So we have 180 plus minus 41.4 degrees. Is that clear to you?
Yeah. So 180 minus that, we get 138.6. Wait, should I round it to?
No, they are not specifying.
Okay, it's 5.9. So
6 is okay. 6 is
okay. 6. And then if I add 180 to that value,
41 plus 180, right?
221.4.
So we have 4 answers: 0, 360, 138.6, 221.4, all in the domain 0.
But we can't have 360 though, because it's
Oh, yeah. Very good. I didn't notice that. It's too small for me.
It's subtle, yeah.
No,
but still, the other ones, they
very important. This is not a part. 0, x is greater than equal to 0, but less than 360. You're right.
Oh, okay.
So that will not be included. Clear.
So it's easy to get carried away, isn't it? Because like the domains, they're really sneaky with the signs. So yeah, I've been called out so many times for that. So I'm going to make sure that's not going to happen anymore.
Good
So,
job.
okay.
Very good.
All right. That
Now,
one's very clear,
very
so
clear.
thank you.
Next question, please.
A bit of trick. This looks like a differentiation.
Yeah.
Okay. Question 9. So a solid glass cylinder, which is used in an expensive laser amplifier, has a volume of 75 pi centimeter cubed. The cost of polishing the surface area of this glass cylinder is £2 per centimeter squared for the curved surface area and £3 per centimeter squared for the circular top and base areas. Given that the radius of the cylinder is r centimeters, Part A, show that the cost of the polishing, which is C pounds, is given by C equals 6 pi r squared plus 300 pi over r. Yeah. Wow, that's wordy.
But I like your test papers because they actually give you the formula and you have to just derive the formula, right?
That's true.
In our times, we were never given the formula and straight we were to do part B or something related. You get the idea.
That's so hard.
In that case, if you get the wrong formula, you don't know where to go, right? I mean, you don't even know how to start, right? Please read part B also and C also.
Okay. So part B, use calculus to find the minimum cost of the polishing, giving your answer to the nearest pound.
Correct.
And part C, justify that answer that you have obtained in part B is a minimum.
Right. So now, my suggestion. We already have the formula, correct?
Yeah.
Let us say you get stuck here and you're not able to do part A.
Right.
Let us say you get stuck and you are not able to part B. You will not get 4 marks, correct?
Okay.
But you know the formula, so you can do part B and C.
Yeah, which is 6 marks. So
which is 6 marks.
Yeah. Okay.
You understand?
Yeah.
In my test paper, I will not be given this part, and I'll be asked part B and C. So I lose all the marks. 11.
Oh.
Do you see? 9, 10 marks I lose.
They've got nice to the examiners. Is that what you're trying to say?
Yes.
Oh my god, that's really hard in your time. I can't imagine.
They will not give me that formula, right? They say you don't even remember the formula for a cylinder. What are you doing here?
Yeah, that's so true. Oh my god.
So this is, in your case, if you get stuck with part A, you can still do B and C and get more than half marks.
Yeah. So don't just reject them just because you can't do A. Yeah.
Yes. So let's do it, right? So it should not be very difficult. So we have the formula, or rather the answer, right? So only thing is we have to find the area of the cylinder. We are given that the radius is r. So area is what? Pi r square is that area, and we have got top and bottom. 2 times pi r square
2
is
pi
the top area, right? So yes. So cost of polishing the surface area of this glass cylinder is $2 per centimeter square for the curved surface area and $3. So multiply this by $3. Is that okay? Pound 3, I'm sorry.
It's all right, sir. I know you're used to dollars.
Yeah. So pound 3 per cubic square. Perfect.
Yeah.
So that is the surface area for top and bottom. Plus, now, what is the curved surface? 2 pi r and
L.
height. Yeah, and height, correct? So how long it is?
The
solid glass surface, which is used.
It tells us the volume. So can we work backwards?
So yeah, L is L or height H, right?
LH, yeah. So many terms.
So we'll have to do 2 parts, correct? So anyway, let me write down here 2 pi r into length, and we're going to multiply this by $2. Again, 2 pounds.
Yeah, no worries. Okay.
Okay, great. But we are given the volume. So volume will let us help find one relation in terms of the other. Volume is pi r square L, right? So pi r square L is equals to 75 pi. Clear?
Yeah.
So pi cancel. And now you know that L basically is equals to 75 over r square. So we got everything in terms of r as a function of r.
Oh, yeah.
So we'll write this and we'll say now the cost is equals to multiply by 3, we get 6 pi r square plus we have 2 pi r. Instead of L, I'm writing 75 over r square and then multiply by.
Oh,
Is that clear to you?
yeah. You're
6 pi r
substituting.
square, correct? And we can now simplify, canceling these r's here. 75 times 4 gives me 300, right? And then r in the denominator.
You cancel the r's. So, wait, 75 times 2 is 150?
Times this 2 also.
Then times the 2, yeah. 300 over r. Oh, that wasn't that bad for 4 marks.
Yeah.
Okay.
So now we have the formula, right? Clear?
Yeah.
Okay. So now use calculus to find the minimum. So what is the concept here? Calculus is derivative, and derivative should be minimum when we have 0 rate of change at that particular point, right? So let's find the derivative. So C prime, or derivative of C, you can also write dc over dr. Is that okay? Differentiate the equation with respect to r. Okay?
Yeah.
When you do that, you get 6 pi times 2. So 2 times 6, I should write 6 pi r. Is it okay? Derivative, 2 times 6 is 12. 12, I could have written directly. And this is minus r to the power of minus 2. So minus 300 pi over
Oh, yeah.
r square. Is it clear to you? Well, you will rewrite this as, I know what you're going to do. You'll rewrite this 6 pi r
to the minus.
Yes.
I don't like that look. It's a bit
r minus 1, right?
Yeah. That's what I like to see.
And then you will say that C prime or dCdr is 12 pi r, and this gives you minus. Is this clear now? 300
minus 300.
R to the power of minus 2. I'm
Minus
not
2.
going there, but I'll write r squared.
Oh, yeah. That's okay.
Perfect.
Yeah.
Now, use calculus to find the minimum cost of polishing, giving your answer to the nearest this. So minimum or maximum, you have to find the critical number, right?
Right. So we have to make that equal to 0.
So when you make equal to 0, so we say C prime is equal to 0, right? That means 12 pi r is equal to 300 pi over r square. Is it okay?
Oh, yeah.
Only then they will be 0, right? So cross multiply, so get r cube equals to 300 over 12, right? Correct?
Yeah.
And now you could divide by, you could simplify and then use calculator. I'll say use calculator, right? Do the cube root of 300. Don't bother about exact answers, right? Just find cube root.
Okay, yeah. So let me just do that.
Nearest pound. Use calculus. First, you have to find r value. Yes, what do you get?
2.92.
Okay, substitute. Now it says, so at this particular radius value, you get the critical number, right? Now you should actually show that this actually is minimum. Is that clear to you?
Yeah.
This actually is minimum. How will you show that?
Second derivative.
You could do second derivative, yes, of course. But you could check the value on left and right side of this. You get the idea?
Oh, yeah.
On the derivative.
Is that when you do the concavity and you it's decreasing?
So just check the value of this derivative at r equals to 2. You get 92, right? So let's say 2.9, and also the value at 3, right? So that means if it is a minimum at this, it will be like minus, right? So it will be decreasing, and at that value, it will be increasing. So it goes from decreasing to increasing. That means this critical number is
a minimum.
You get the idea. So you can do interval and figure this out. Is that okay?
I see. Yeah.
Right. Yes. You can, of course, do the second derivative. And if second derivative, because it is concave up, it has to be positive. So if the second derivative is positive, which is positive, by the way, and second derivative is simpler, because if I do second derivative, this term is 12 pi. Is that clear?
Yeah. Oh,
And
good.
this term is positive. Do you see? Minus 2 will give you positive
minus
2 times. 2 times this is 600, right? 600 pi divided by r cube. Okay, so both are positive terms, and therefore you can say when c second derivative is greater than 0, that means we have a minimum. Is that clear?
Yes.
So both methods, in this case, actually second derivative is easier and faster.
Yeah, but it's good to, like, you know, double check with your method, because yours is like really precise with the intervals, because you can't really go wrong with that. Yeah. No, like if I have time, I can go back and look at that.
Yeah. So you have to show this one. The idea here is you have to show your work. Do not just assume that that critical number is a minimum. Is that okay?
Right, right.
Now we are sure about it. So now you substitute r. So find the value of the cost. You need to find the value of the cost, right? For 2.92, and substitute 2.92 and calculate your answer.
Oh yeah, we only calculated r this whole time. We didn't even find the costs. Oh yeah.
So when you read the question, highlight what you really want to find. Otherwise, you get lost in it, right?
Yeah, I got lost in it.
Yes.
Oh yeah, minimum cost. Oh, that was a key point.
Yes.
Oh God. Okay. So yeah, C of 2.
But they are saying justify that the answer you have obtained in part B is minimum. We did justify by taking the second derivative, right?
Right.
In my test paper, they will not write that statement. And if you
have
don't do it, they will deduct 1 mark.
Really?
Yes. You have to justify. But in your case, see,
they tell you
a hint. They're saying part C is justify your minimum. You get the idea?
Yeah.
And so I just did it, right? I never looked for part C, because we are used to, you have to give a complete solution. You just can't give a partial solution, right? So this is very important to understand. Is that okay?
Yeah. No, that's why I've noticed, like whenever I give you exam questions, you just read the question and then you just like you don't even read. You read the context and then you don't even read the question. Then you somehow answer every question that's on the page or more. Yeah, or more. You just answered everything. I'm like, whoa. Yeah. So yeah, I guess you're used to doing that.
To be very frank with you, when I see your test paper, I say, why they are asking part A, part B, part C?
Yeah. Just ask the one. Don't make it harder.
They're making it simpler. I mean, they're guiding you to answer. They're actually guiding you. They're helping you. They're providing hint at every step. And the best part is, if you don't know step 1, you can still do 2 and 3.
Follow through. Oh. So yeah, I don't want to really do badly then, because you're saying like you got help, you got a guide. So it shouldn't be that hard, But
it shouldn't be. See, they give you very strong clues. First, they have directly given you the formula. And did you do that? Or you're going to lose 1 mark? They're asking you that.
Yeah, basically.
You have to justify. In any question in calculus for maximum minimum, you have to justify. Is it
right? Yeah. No, because I've actually seen questions where it's been a 6 marker. See that 5 + 1 is 6 marks,
Yes.
But they wouldn't have this part C. So like you said, you would just have to do it automatically. But in this case, they broke it down literally for the 1 mark telling you. So that was nice. Yeah. All right.
Let's move on. Is this clear? Absolutely clear to you?
Yeah, very clear.
Great. So let's share the next question now.
Oh, graphs.
Okay. Yeah.
This is a nice variation. So far, I'm liking all the topics that came up. Okay. I think when we hit vectors, that's when I'm going to leave.
Okay.
I'm joking.
What is the question here?
Figure 3 shows a sketch of part of the curve C with the equation y = x multiplied by x + 4 times x - 2. The curve C crosses the x-axis at the origin O and the points A and B.
Correct.
Write down the x-coordinates of points A and B.
Yeah, we wrote it, right? -4, 0 and 2. Correct. Now,
2.
Next part.
The finite region shown, shaded in figure 3, is bounded by the curve C and the x-axis. Use integration to find the total area of the finite region shown in the shaded
Correct.
region. Yeah. I think
Now,
that's just simple steps. Yeah,
the
using
integral, yeah.
integration.
So you
But
can absolute value, right? Because area is always positive, right?
right. And also you have to do like, so find the area between -4 and 0, and then 0 and 2. Like, don't just do -4 to 2, because
Yes,
that
yes.
will get the wrong answer. No,
Yeah.
because I
You
remember a couple of
find,
my friends doing that.
yes, yes,
Yeah.
yes. So -4 to 0 and the function f of x. Let me write like this, right? And then you have to use the absolute value. So when you say um, the finite region, so this is bounded by the curve, right? Write down the, oh, we did this part. Now part B is use integration to find total area. So when you add, you have to do absolute value from 0 to 2, right, of your function. Is that clear to you?
Yeah. Yeah.
Perfect, right? Absolute
And
value.
to
Of,
integrate, should I expand that all out?
no, yeah, you have to expand that all out. So your function y is equal to, just expand it, right? So first
Yeah.
you multiply as you wish, and you do that x squared
X
minus
squared.
2x, and then you get 4x minus 8, correct?
Yeah.
And then you have x times x squared plus
Plus
2
2x
minus
minus 8.
8, and then you have x cubed plus 3x squared minus 8x, right? So that is your function. I'm writing f of x as I've written here. That becomes your function, correct? And you know
Right.
the rules, right? Power rule. I mean, you have to use to get your answer. Is that clear to you?
Yes. Very.
Very simple. Okay, so you can move on to the next question. Yes, can you please read this?
Yeah. So the circle C has radius 5,
Mhm.
and touches the y-axis at the point 0, 9, as shown in figure 4. Part A, write down an equation for the circle C that is shown in the figure 4.
Sorry. So that's
So we got the radius,
Mhm.
and we got the
The
y-axis.
center, 0 and 9, right? So -5 and 9 will be your center, correct? The circle of radius 5. So that means this point here is 5, right? So you have, let's call this as the circle C, means the center point is C, right? So the center point is given to us as -5, 9. Is that clear to you? Radius is given to us 5. Is it correct?
Wait, so when you said the point is 9, is that just by looking at the diagram?
Yeah, it's changed at 9, right?
Okay,
They've
good.
written here. They've written here. It touches the y-axis at 0, 9, correct? So it's tangent.
Oh, yeah. And if it's a tangent, when you do the radius from it, it'll go through the center.
Yeah. So very simple, right? So you got x plus 5, because minus minus becomes 0, right? Plus y squared, right? Because
Yeah.
y moves 9 units up, right? So y minus
9,
whole square equals to 5 squared.
25. Yeah.
Right? So write down the equation, but you expand and write it in standard form if required, but that is also okay, I think.
Oh, all right. Okay. Because they haven't specified, it doesn't matter, does it?
It doesn't matter. Yeah, you could write it like this. But I think
Okay.
in your case, they always expect in standard form.
Oh, okay.
It is actually 3 marks. So that's why I'm thinking, right? We may be thinking what is the center and what is the radius. Two things is that, and then writing the equation. So I think 3 marks is justified. So we have the equation and the 2 points, correct? Yes. Can you please read the next part?
Yes. So a line through the point P, which is 8 minus 7, is a tangent to the circle C at the point T. Part B, find the length of PT.
Correct. So this is the kind of question, right? Find the equation of both the lines. In that case, also, there are 2 lines. You get the idea?
Yeah.
That pass through the point this and are tangent to a parabola. So we have a parabola. That is also a circle.
Right.
So it passes through, like it was given 8 and -7, and is tangent to a curve. Let's say that, correct?
Yeah.
So important thing here is that the given point is not on the parabola. It is somewhere outside. You get the idea. So when you look at this solution, you will understand that I'm trying to find the tangent in 2 different ways. One is using the slope That is the calculus part. And second is y2 minus y1 divided by x2 minus x1. Do you see that?
Yeah.
So this part is the slope which you find normally for any line, y2 minus y1, gradient I should say, y2 minus y1 divided by x2 minus x1. And that's
Yeah.
the derivative part. The next part is the derivative part. So y prime is 2 minus 2x, correct?
Yeah.
Or
Because
this
you
is
differentiate.
very good.
Yeah.
So y prime at, we don't know the point, so let the point be a and b. So we'll put a here, and b, of course, is very simple because the equation is 2x minus x squared. B is 2b minus b
Yeah.
squared. So that is why you have to write y in terms of x.
Oh, so it's all in the same, same subject. I get it.
And
Okay.
then you figure it out. It takes time, and this question should have been worth much more. Do you get the idea?
Yeah.
Hmm.
So I'm gonna watch your video and then I'll solve it, and then let me
Yes.
see if I get the same answer.
Yes. So watch the
Okay.
video. That should be better for you.
Yeah.
So now I think,
That's good.
can you review what we learned today? We can end the class here today.
Yes, definitely. Okay. So yeah, we kind of did a lot. Like, it's hard because I haven't done any like prep before this like lesson, but it's surprising to me because I didn't forget that much, and it's just over the like time of like last year as well because I've been with you so like quite a lot now. It is like all just now sticking in, and it's good now because I don't want to. It's hard to just keep reviewing every topic because like things get in the way, other subjects and stuff. It should stick there. So I feel like it is now because we were kind of thrown with a lot of questions. So I just wrote the topics down just so I can talk back. So we did a bit of logarithms and not exponentials, just the logs, the natural logs. The key thing I learned from there, it was just about when we found our value, the subbing it back into the equation is just so important because we want to check if our answer's right. And if we have the calculator available at any point throughout and you just want to check, always check with the calculator because you can't go wrong there. And then for the special triangles question, so whenever I see like you said, so root 3 and things, just immediately draw up the special triangles just to be safe. And then a critical step was all this I've noticed. So if we did a trig question and you like subbed in a value, so we said tan pi over 3 was root 3, you just subbed it in. Even in another question, we were doing something and then we found the value. So let's say, it was the surface area, the cylinder one. Yeah, we found the length, the height of it as like in terms of r, and you just subbed it in. So I can see that's like a regular thing that it's like coming up as a technique to do, and it's so much better because what I always used to do was like find a value, but not in terms of like the question was asking. Yeah, variables.
Derive the formula. Derive the formula. Write the expression, right? And at the end, substitute the values to find the answer. You get the idea.
Yeah.
You get marks for every stage. Now, what I've seen here is sometimes when you derive the formula correctly and substitute and get the wrong answer because of wrong calculations, teachers won't deduct your marks.
Because they can see you're working through it's just a mistake.
Yeah, it happens. They don't deduct the marks.
Right. So yeah, that's really important then. So yeah, working with variables, and you want to keep your variables really to the minimum. If you can write something in terms of something else, like we just discussed with the circle, if you can write A in terms of B and then work it out like that, do that. Don't have A, B, C, D, because then afterwards you just get so many equations with too many variables and you can't cancel them out. So that's also another important thing. And then just a simple integration, differentiation, and all these little rules that you just keep in mind. So yeah, it was a really good review of like kind of everything.
It was. I mean, you selected the right kind of questions at random. It happened.
Yeah, I didn't know.
We had exponential and logarithmic functions. We had trigonometry, and we had calculus, which involved differentiation as well as integration, right? So
and some graphs.
Question based on minimum. So everything was covered. That was beautiful.
Yeah.
So I love that spread which you covered in this.
It's good variety, because it's just going to be like the exam, because I have done, because when I do exam questions only for a topic, I get them all right. But then obviously that's because I'm in the mindset. When your mindset's like everywhere, it does play a trick on you. So it's good to get back into that like routine, I guess.
It is.
So thank you so much, sir, for your help. Pleasure. That was like super helpful.
My pleasure. Thank you. Have a good day.
Help to everyone else. Thank you, sir. Bye. Have a good rest of your day.
You too. Thank you.